Hello everyone, welcome to this channel. So in this video, we will continue our topics in probability. So in this video, I want to finally introduce the probability and some rule about it. So in previous videos, we already talked about some terminologies like what is an experiment, what is an event, and some rule about the size, because a sample space and events are all size. So in this video, let us introduce what is probability. So probability actually is a function assigned to events of a sample space to represent the belief in what the outcomes of one experiment are likely to be. So in other words, you can think this is if we have some outcomes in a sample space, then we can say these outcomes will be happen more compared to the other outcomes, or this will less likely to happen. So this is the idea of what is a probability. So to set a probability, there are several ways to set it. So in general, we can divide this to a subjective one or an objective one. So for the subjective one, it means we just guess. For example, we guess, okay, tomorrow will raining by just guess it's maybe probably happen, or tomorrow will be a sunny. So this is just we guess it based on a one-time event. We don't have any in case like we don't have any knowledge about this, we just guess it without any fundamental about this. For the objective one, it means something maybe it happens multiple times in a sample space, or in other words in an experiment. So then we can just use the relative frequency of this event to help us find how to set the rule. For example, if we flip a coin, and if this coin is a fair one, then we can flip this coin like 1,000 times, and then we count how many tail we get, how many head we get. And in general, the possible we get a head or a tail is same. So then we can use these outcomes happens again and again in several experiments to help us set a more objective probability of this one. Okay. So in the video about the sample space, we say the sample space, we can have a discrete sample space or continuous sample space. For discrete sample space, it means we can list the outcomes in a sample space. So here, if we assume the S, which is our notation for the sample space, this is a finite and discrete sample space. So in other words, when we list all the outcomes of this sample space, we can find a maximum order of this. However, this number can be very large, so we can have something about like 1,000 outcomes here. We also can do this like if this all we have like 1 million possible outcomes. However, no matter what this number, how large it is, we always can find a maximum number of this one. So that's why this is a finite discrete sample space. And then how to find the probability of this one? So it means we will set a probability for each of the outcomes. So we assume we set the P sub I to the outcome OI. Then for the samples, for the probability of this one, we can have some requirement of them. So let's see, because the P probability of OI is the likely, describes the likely this OI will happen or not. So we can say if something is never happen, we can set this P sub I as a 0. However, it cannot give any negative value to it, right? So, and also if we set it like 100%, in other words 1, so that means for sure this will happen. But we can now say some number larger than this. So in other words, the value of pi should be between 0 and 1. And then what's the next requirement is we also need to require the sum of our pi should no larger than 1. So why the sum of the pi is equal 1? Because for the pi, this one is to describe the OI will how likely this will happen. So if we sum up the pi, it's kind of like we think about when think about O1, O2 until O capital N, right? This will happen or not. So when we sum up the pi, it means for a sample space, we only have n outcomes. So no matter we like flip a coin or roll a dice, at least we can get something, right? We can get an outcome. So if we think about this union kind of all of the sample space, then for sure it will happen. So that's why, because for our sample space we only have n outcomes, so that's why if we think all of them, the probability of something happening inside the sample space should equal 1. So this is some rule or requirements we will have for the probability of each outcomes. And then the next thing is, for sample space, we also have the events as the subsets of a sample space. And then how we can get the probability of a subset. Assume the event is denoted by E, then the probability of E is denoted by the P parentheses E. And the answer of this one is a sum all of the I which give us OI in E and PI. So what this means? This means we will sum up all of the weight PI when the OI, this outcome, is in our event E. So this is a way to get the probability of our event E. Okay, so let me give you a short example of this. So the question is, if we have a sample space with 3 outcomes, A, B, and C. And here for these 3 outcomes, their weight is assigned to 0.1, 0.5, and 0.4. So then the question is, when we have an event as only contain A and C, then what is the probability of this one? So here to solve this one, of course, we can just use a formula. But before this, I want you to look at the 3 weight. So here we can have the weight is 0.1, 5, and 4. So in fact, the first thing we know all of them is between 0 and 1. Right? So this means this question is correct. And then the second is the sum of them is equal 1. So that means in this question, actually the side of this weight is correct, because the weight satisfies these 2 requirements. And then to compute the probability of E, actually this is just use a formula. So that means we need to check what's in our E. We know the A and the C is in our E, right? So we just sum up this formula, their weight. So because the weight for our A here is 0.1, and then the weight for our element C is 0.4. So that means to sum up them, this is a 0.1 plus 0.4. So the answer of this question is 0.5. Okay, so this is an example how we can set the weight to a finite discrete sample space, and then by this ways how we can compute the probability of one event. So then for the finite discrete sample space, there is a one special case. So for this one, we call this is equally likely outcomes. So that means here we assume in this sample space we have n possible outcomes. However, for all of them, their weights are exactly same. So in other words, they have the equal possibility to happen. So because we have the sum of all the weights should equal 1, here we have n outcomes. So that means the weight for each of the outcomes should be 1/n. So now when we talk about an event of this sample space, the probability of this event will become kind of more straightforward. So then for an event E, then we denote the outcomes in this event, the number as a kind of like absolutely value of E. Then the probability of this event will be much simple. So you just use the number of the outcomes in this event divided by all of the numbers of outcomes in our sample space. So this is how we can compute the probability of event when the sample space have the equally likely outcomes. Okay, and so before the end of this lecture, I want to talk about the one important axiom of probability. So here there are three rules of our axiom here. The first one is the probability of our sample space is 1. So this is similar with the weights, the sum of the weights should equal 1. And the second is for any event, the probability of this event should be between 0 and 1. So because this event is a subset of our sample space, if the event is empty, then they will for sure get a 0 value. And if this event is same with our sample space, then for sure the value will become 1. And then all others is number will be between 0 and 1. And then the third one is if our two events, E1 and E2, they have no intersection, or in other words, their intersection is an empty set, then this E1 and E2 are mutually exclusive, and the probability of the union of these two events is equal to the sum of the probability for each of them. So this is three rules of our probability. And here for this rule, actually we have in this one we have this is mutually exclusive. So in fact, for mutually exclusive, we can extend this to more events. So here we just say there are two events, and I can write this as a maybe remark. So here, if we have a several event, so for example, I denoted by E1, E2 until E sub n. And for this, if they are pairwise mutually exclusive. So what this means? This means if we choose any event inside this, any two events in this n events, then the intersection of them is an empty set. So this means the pairwise mutually exclusive. And then if we have this requirement, then what we will have the probability of the union of all of these events will just equal the sum of the probability of each event. Okay, so this is kind of like an extension of our two events are mutually exclusive. So this is what I want to talk in this video, and in the next video I will start to talk if we have several events and we want to compute them, like we take intersection union of them, then how we can compute the probability of them. So of course now these two events are not mutually exclusive. Okay, so thank you for watching this video, and hope I can see you. You can watch my next video.